Hello everyone! Today we will have a new lesson about types of RAM or random access memory. What is internal memory and how is it different from external memory? Computer memory is generally classified as either internal or external memory. Internal memory, also called main or primary memory, refers to memory that stores small amounts of data that can be accessed quickly while the computer is running. External memory, also called secondary memory, refers to a storage device that can retain or store data persistently. They could be embedded or removable storage devices. Examples include hard disk or solid-state drives, USB flash drives, and compact discs. What are the types of internal memory? There are basically two kinds of internal memory, ROM and RAM. ROM stands for read-only memory. It is non-volatile, which means it can retain data even without power. It is issued mainly to start or boot of a computer. Once the operating system is loaded, the computer uses RAM, which stands for Random Access Memory, which temporarily stores data while the Central Processing Unit or CPU is executing other tasks. With more RAM on the computer, the less the CPU has to read data from the external or secondary memory or storage device, allowing the computer to run faster. RAM is fast but it is volatile, which means it will not retain data if there is no power. It is therefore important to save data to the storage device before the system is turned off. Let's talk about what is RAM. The full form of RAM is random access memory. The information stored in this type of memory is lost when the power supply to the PC or laptop is switched off. The information stored in RAM can be checked with the help of BIOS. It is generally known as the main memory or temporary memory or cache memory or volatile memory of the computer system. How to identify the types of RAM and their specifications? There are many different types of RAM which have appeared over the years, and it is often difficult knowing the difference between them, both performance-wise and visually identifying them. This content tells a little about each RAM type, what it looks like, and how it performs. What are the types of RAM? There are two main types of RAM, dynamic RAM or DRAM, and static RAM or SDRAM. Static RAM or static random access memory. In this type of RAM, data is stored using the state of a 6-transistor memory cell. Static RAM is mostly used as cache memory for the processor. SRAM is made up of 4 to 6 transistors. It keeps data in the memory as long as power is supplied to the system, unlike DRAM, which has to be refreshed periodically. As such, SRAM is faster but also more expensive, making DRAM the more prevalent memory in computer systems. Dynamic RAM, or DRAM, stands for Dynamic Random Access Memory. It is a type of RAM which allows you to store each bit of data in a separate capacitor within a specific integrated circuit. Dynamic RAM is a standard computer memory of the many modern desktop computers. DRAM is widely used as computers' main memory. Each DRAM memory cell is made up of a transistor and a capacitor within an integrated circuit, and a data bit is stored in the capacitor. Since transistors always take a small amount, the capacitors will slowly discharge, causing information stored in it to drain. Hence, DRAM has to be refreshed or given a new electronic charge every few milliseconds to retain data. Let us see the difference between the SRAM and DRAM. SRAM has lower access time, so it is faster compared to DRAM, while DRAM has higher access time, so it is slower than SRAM. SRAM is costlier than RAM. DRAM costs less compared to SRAM. SRAM requires a constant power supply, which means it's type of memory which consumes more power. DRAM offers reduced power consumption because the information is stored in the capacitor. It is a complex internal circuitry and it offers the storage capacity is available compared to the same physical size of a DRAM memory chip. While the DRAM, it is the small internal circuitry in the 1-bit memory cell of DRAM, the large storage capacity is available. SRAM has a low packaging density, while the DRAM has a high packaging density. But what are the common types of DRAM? SDRAM, which is short for Synchronous DRAM, is a type of DRAM that runs in a synchronization with the memory bus. Beginning in 1996, most Intel-based chipsets began to support SDRAM, which made it a popular choice for new systems in 2001. SDRAM is capable of running at 133 MHz, which is about 3 times faster than FPM RAM and twice as fast as EduRAM. Most Pentium or Celeron systems purchased in 1999 have SDRAM. Synchronous DRAM synchronizes the memory speed with CPU clock speed so that the memory controller knows the exact clock cycle when the requested data will be ready. This allows the CPU to perform more instructions at a given time. Typical SDRAM transfer data at speeds up to 133 MHz. Next is the Rambus RDRAM. It's a type of RAM of its own. It came out in 1999 and was developed from the traditional DRAM, but its architecture is totally new. The Rambus design gives smarter access to the RAM, meaning that units can prefetch data and free some CPU work. The idea behind Rambus RAM is to get small packets of data from the RAM, but at very high clock speeds. For example, SDRAM can get 64 bits of information at 100 MHz, where Rambus RAM would get 16 bits of data at 800 MHz. RIMM RAM was generally unsuccessful as Intel had a lot of problems with the RAM timing or signal noise. RDRAM did make an appearance in the Sony PlayStation 2 and the Nintendo 64 game consoles. Rambus DRAM takes its name after the company that made it, Rambus. It was popular in the early 2000s and was mainly used for video game devices and graphic cards with transfer speeds up to 1 GHz. DDR-RAM, which stands for Double Date Rate, which is a type of SDRAM and appeared first on the market around 2000, but didn't catch on until about 2001 when the mainstream motherboards started supporting it. The difference between SDRAM and DDR-RAM is that instead of doubling the clock rate, it transfers data twice per clock cycle, which effectively doubles the data rate. DDR-RAM has become mainstream in the graphics card market and has become the memory standard. Double data rate SDRAM is a type of synchronous memory that nearly doubles the bandwidth of a single data rate or SDRAM, running at the same clock frequency by employing a method called double pumping, which allows transfer of data on both the rising and falling edges of the clock signal without any increase in clock frequency. DDR2 RAM, which stands for Double Data Rate 2, is a newer version of DDR which is twice as fast as the original DDR RAM. DDR2 RAM came out in mid-2003 and the first chipsets that supported DDR2 came out in mid-2004. DDR2 still is double data rate just like the original DDR. However, DDR2 RAM has modified signaling which enables higher speeds to be achieved with more immunity to signal noise and crosstalk between signals. DDR1 SDRAM has been succeeded by DDR2, DDR3, and most recently DDR4 SDRAM. Although operating on the same principles, the modules are not backward compatible. Each generation delivers higher transfer rates and faster performance. The latest DDR4 modules, for example, feature fast transfer rates at 2133 or 2400 or 2666 and even 3200 seconds. There are other important types of RAM. The FPM RAM, which stands for Fast Page Mode RAM, is a type of dynamic RAM. The term fast page mode comes from the capability of memory being able to access data that is on the same page and can be done with less latency. Most 486 and Pentium-based systems from 1995 and earlier used FPM memory. The fast page mode dynamic random access memory is a type of RAM that waits through the entire process of locating a bit of data by column and row and then reading the bit before it begins on the next bit. Max transfer rate is around 176 Mbps. Next is the EDU-RAM, which stands for Extended Data Out RAM. Came out in 1995 as a new type of memory available for Pentium-based systems. EDU is a modified form of FPM RAM which is commonly referred to as hyperpage mode. Extended data out refers to the fact that the data output drivers on the memory module are not switched off when the memory controller removes the column address to begin the next cycle, unlike FPM RAM. Most early Pentium-based systems use EDU. EDU DRAM is an abbreviation of Extended Data Output Random Access Memory. It doesn't wait for the completion of the processing of the first bit before continuing to the next one. As soon as the address of the first bit is located, EDU DRAM begins looking for the next bit. Next, RAM optimized for video adapters is called VRAM. These chips have two ports so that video data can be written to chips. At the same time, the video adapter regularly reads the memory to refresh the monitor's current display. Next, flash memory. Flash memory is an electrically erasable and programmable permanent type of memory. It uses a one-transistor memory to store a bit. It offers low power consumption and helps to reduce the cost. It is mainly used in digital cameras, MP3 players, and so on. Let's proceed to what are the types of DRAM packages. Single Inline Memory Module or SIMM were widely used from the late 1980s to 1990s and are now obsolete. They typically had 32-bit data bus and were available in two physical types, the 30 and 72 pin. Another types of DRAM packages is the Dual Inline Memory Module or DIMM. Current memory modules come in DIMM. Dual inline refers to pins on both sides of the modules. A DIMM originally had a 168-pin connector supporting 64-bit data bus, which is twice the data width of SIMM. The wider bus means that more data can pass through a DIMM, translating to faster overall performance. Latest DIMM based on 4th generation double data rate or DDR4 SDRAM have 288-pin connectors for increased data throughput. What are the common types of DIMM? There are several DIMM architectures. Different platforms can accommodate different memory types, so it is best to check which modules are supported on the motherboard. Here are the most common standard DIMM with a typical length of 133.35 mm and height of 30 mm. First, the Unbuffered DIMM or UDIMM. Used mainly on desktop and laptop computers, they run faster and cost less but are not as stable as registered memory. Commands go directly from the memory controller residing in the CPU to the memory module. Followed by fully buffered DIMM or FBDIMM, typically used as main memory in systems requiring large capacity such as servers and workstations. FBDIMM use advanced memory buffer or AMB chips to increase reliability, mainly signal integrity and improve error detection methods to reduce soft errors. The AMB bus is split into a 14-bit read bus and a 10-bit write bus. By having a dedicated read or write bus, reads and writes can happen simultaneously, resulting in increased performance. Lesser pin counts, or 69 pins per serial channel compared with 240 pins in parallel channels, result in lesser routing complexity and allowing smaller board designs for compact, small form factor systems. Next is the registered DIMM or RDIMM, also known as buffered memory, are often used in servers and other applications requiring stability and robustness. RDIMM feature onboard memory registers, hence the name registered, placed between the memory and memory controller. The memory controller buffers command, addressing and clock cycling, directing instructions to the dedicated memory registers instead of accessing the DRAM directly. As a result, the instructions could take approximately one CPU cycle longer, but the buffering reduces the strain on the CPU's memory controller. And last type of DIMM is the load-reduced DIMM or LRDIMM. Use isolation memory buffer or IMB technology, which reduces the load on the memory controller by buffering both data and address lanes. Unlike the register on RDIMM, which buffer only command, addressing, and clock cycling, the IMB chip also buffers data signals. The IMB chip isolates all electrical loading, including data signals of the DRAM chips on the DIMM from the memory controller. The IMB chip isolates all electrical loading, including data signals of the DRAM chips on the DIMM from the memory controller. So the memory controller only sees the IMB and not the DRAM chips. The memory buffer then handles all reads and writes to the DRAM chips, boosting both capacity and speed. So what are the uses of RAM? Here are important uses of RAM. RAM is utilized in the computer as a scratch pad, buffer, and main memory. It offers a fast operating speed. It is also popular for its compatibility, and it offers low power dissipation. So that's all the discussion about the types of RAM or random access memory. Thank you for watching and have a nice day.